Hello, it's Becky, and I'm going to address a high school science standard. So it's the next generation science standards, and this is for specific to life science, and it's actually HS-LS1-1. And I'm going to read off the standard because it's big. So it says construct an explanation based on evidence for how the structure of DNA determines the structure of proteins which carry out the essential functions of life through systems of specialized cells. So how I would address this is actually through two different ways. So I do this through think, pair sharing and through progress monitoring groups. So specific with the think, pair sharing, it would be collaborative with 2 students at a time. And they could use text, they could use web, they could work together to basically problem solve and understand DNA, the basis of DNA, genomics, sequences, and understanding how DNA is made up of proteins and how that works. So this would just be like the base understanding of what's going to be presented for them as far as just the background. And they could write things out together and then also collaborate on a piece together as far as what they've learned. So then it would take, let's say, 2 different sets of pairs, so maybe 2 different groups of students of 2, and create a group of 4 to do a progress monitoring group. So within that, I would develop a project, preparing the students into a group, and give students the manage their, just basically manage any issues that might have, just give them some concrete examples and expectations of what they're going to do in the group, and then of course provide feedback and monitor the group. So how these 2 things would work, specific that the think pair sharing, students would work together again with the text, web, resources, identifying the structure, understanding proteins, genetic sequences, gain base knowledge, and then within the group itself, the monitoring of the group, I would allow them to creatively figure out, give them 3 or 4 different suggestions as far as how they could work together in the group and what they could do to build out a model. So they would be building a DNA model, right? So this could be structurally model, actually using materials. This could be through art form itself, particularly maybe artistic students patch with those who really like to engage with writing. So one does the art, the other does the writing and explaining of the art. And then the other one would be like a computer simulation. There's quite a few different simulation modeling programs out there for DNA right now, and that would be really great. And then each one of those groups could then share in class the other people's knowledge and present their group project around DNA and its structure. So this particularly is going to hit the theory of differentiated instruction. So students learn best when teachers accommodate readiness levels, interest, and learning profiles. So of course there's a standard that needs to be taken into account, but by giving them different opportunities and different ideas for them to be able to express the DNA, that would be where it would work. So the last is making a connection. So I actually did this years ago, and I had students model DNA. It was in a younger setting, so it was a third grade through 6th grade setting, but we actually made DNA models using, we used candy. So we used, for the younger grades, we just used marshmallows as the base pairs, and then we used red vines as the actual helix of, basically making a DNA helix. And then we used, for the other group, we used kind of like little gummies that were different colors because there's 4 different, base pairs, and we modeled those out. And so we had kind of a project where we had a station where they could do that, and then another station where they're actually drawing out the base pairs and then kind of synthesizing it. So it basically took the whole initial think pair sharing where they needed to understand what each one of the things that they were doing was and what DNA was, and then actually created a model, and then they shared each other's projects, and then they ate the projects at the end, which is always fun. So I believe that in high school we could do something similar. It would just be a little bit more extensive and in detail. So that is it.